Okay, thank you. Welcome back for this session. So, and this today we will be looking around the combination of Kubernetes and Linkerd or Linkerd, popularly known as Linkerd. Before we talk about the technical implementation and a bit of demonstration, we need to do a little glimpse around what is Service Mesh and how things are working and what is the need of Service Mesh. So I'll be taking through a very quick introduction to Service Mesh, and in this session we'll be talking about Linkerd, and probably in a couple of other sessions we'll do some integration with Istio and Console Connect as well. Okay, now if we say Service Mesh, to give you some perspective, of course this is not a group of services, this is not a mesh of services and stuff like that. And just to give you some perspective also, the service mesh, is it a specific concept after Kubernetes and containers? No, this was there before. And can that be used only with Kubernetes or containers? Not really. So when you get to know what is service mesh, you can actually realize this can be used in multiple other perspectives. So before we going into the kind of what is so called a definition, and trying to understand more, let's trying to bring a problem or perspective here. For so whatever that we discuss more from a Kubernetes perspective here. So let's assume there's a company, an organization which is running applications, basically different set of services. And these services are actually interdependent. So for example, we have a web service which is dependent on DB services, and you have some kind of broker services which is connecting between different other services, etc. When it is on the small scale, when it is less in number, it is very easy for the administrator or even developers to manage it and to control the way they want. At the moment when in any enterprise and organization, or even for us when we look at it on the previous demonstration, what we have seen, we have thousands of nodes and 10,000s of nodes that we are talking about. That's the scale that we are talking about. So a couple of things that will come here. One is, of course, how do you make these transaction between different services so secure? So the counter argument here is, you can say you have firewall, you have some kind of policies, you have network, etc. But that's much more on the peripheral, much more on the upper layer. And most of the organization, when we look at it, once after you cross that border of first level of security control, inside is much more of a flat namespace of flat networks, and at the security perspective from a service point of view, this is much more flat in many of the organization. And the other aspect that we have, when we have more and more services, this is going to be very difficult to identify the interdependencies, to identify the dependencies of services that is connected to many other services or vice versa, and how do we manage it from a centralized part. This will also create another set of concern in terms of how do you manage the resiliency of my services, especially when I'm talking about the network traffic. So that's a different problem that we see in the IT landscape when we actually do a lot of services that brings up to different enterprise applications. And specific to the context of Kubernetes, one word here, because service mesh was there even before Kubernetes or containers, but then bringing Kubernetes actually increased the adoption of microservices, or I would say very easy to manage a service-oriented application or SOA perspective, and that actually demands quite a lot of need in terms of traceability of different services and their network transactions. And security came into a big concern in terms of the end-to-end encryption, TLS, and how do we really implement a zero trust model. And then the other aspect is the communication also, that actually brought into the concept of service mesh. Now to give you some kind of definition, so let's assume this is like a control or a measure that actually manages the different parts of an applications or different services that is actually accumulating to an applications. Or we can say this is like a separate lightweight infrastructure. This is sitting separately than the actual infrastructure, and making more easiness in terms of traceability of application, ensuring more security, and easing up the communication with proper resiliency. So if you go a little deeper, when we have multiple services and they are interconnected in microservice world or service-oriented architecture, one of the key things that we need to see, we should be able to trace it well. This is something, again, I would say most of the time when we have a troubleshooting perspective, you guys would have realized it's so complicated to troubleshoot when we have, let's say 50 or 100 services that are interdependent and they're actually contributing. So you may have to go literally to each of these services and start troubleshooting the way they want. Do we really have an out-of-the-box solution, or sitting out of the service or pod, and can we do a trace until you implement service mesh? The answer is no. So if I put some perspective on traceability, I would say we really need to do an open tracing. Sitting outside of your service or pod, you should be able to trace the transaction between different services. And of course, you really need a lot of metrics and KPIs and key performance indicators, and many a time we have a lot of KPIs, but in different format, and correlating these metrics is actually a tiresome job. But Service Mesh will make this more easy for you. Distributed tracing, you really need to trace in the way that you want, and we really need to correlate, but we do not want to have one central tracing model. And observability, we really need to observe and to see the transaction between services when there is certain hiccups coming up on the application, and we need to see where it is going wrong. The other interesting aspects of Service Mesh is discovery. When we have more and more services coming in, and if you see with Kubernetes, the number of services that is getting deployed will be very much fast day by day. We really need to have a mechanism that will easy and efficient in terms of discovering the services and registering to a certain centralized location, so that when we want to do some kind of traceability, we would like to see quickly that this is a service and this is doing this kind of perspective and this has sort of this dependency. So traceability is one of the key element that is actually help accelerating by using the service mesh. I will quickly cover it because we need to do a demonstration with the Linkerd. Another aspect is security, and as I said, most of the time when we see, once you are into the cluster, once you are into the service level for a specific application, it is more of a flat network. So this is actually a challenge. Like, how do we segregate these services better? How do you ensure end-to-end encryption and TLS and stuff? This is more aligned to the zero trust model, that we don't trust any of the services by default, but based on the TLS and the policies that we define, we can say this web service can talk to this DB services for right now, or probably you can actually change into the way that you want based on implying certain security. Authentication, so this is a very interesting topic. Most of the time when we see authentication, the authentication is happening much more at the application layer but not at the service layer. But with Service Mesh, you can actually do much more granular authentication at the service layer, and every control that you do, you can go till to the edge, and you're actually giving the decision at the edge. You are not doing the decision at the centralized location. You're actually giving this power to the service level, and you can manage it at the edge. That covers the last point. You can have the explicit control. You can say, against this specific service or services, I need sort of control when somebody is trying to connect, when certain traffic is coming in, and this can be managed at the service layer. You can actually set the policy, impose it through the centralized mechanism using Service Mesh. However, this control can happen at the edge, so there is no going back to the centralized mechanism and then coming back, unless this service that need to use some kind of centralized, like a platform bus or some kind of Docker services. This can be easily managed at the service layer itself, so there is no burden to going back to the centralized location, and that can be achieved using Service Mesh. So security is a key profit or benefit that Service Mesh is giving you for your Kubernetes infrastructure. The last part I would like to summarize like a communication. I'm more talking about a kind of network related communications between different services, especially the data flow, proper routing, okay. And I think I made a small spelling correction. Yeah, I put this. Sorry about that. Okay, yes. So this will actually give you some kind of easy and better load balancing than fixing it with an external load balancer. Using Servicemesh, you can say where is the right set of free service that I can attack, and what is the best service in terms of load accumulation that I can manage it. This is also ensure the resiliency, that you are not dropping any network call when a certain service is not available. There's an interesting feature that you can control using Servicemesh. It's called circuit breaker. This is like you have 3 services, and because of the service number 2, there may be a chance of getting a kind of side effect when service number 2 is going wrong. This can affect service 3. Okay, but when the microservice world, the service 3 may have another set of services that is depend on it and working fine. So an impact on service 2 does not need to go to service 3, and you should be able to do a circuit break when such kind of cascading failure effect. And of course, this is very important today. Even if you say when you have different mechanism to manage this control, it depends on the protocol. You have different mechanism, but with using Servicemesh, this is actually helping us to have a kind of centralized mechanism that support on multi-protocol like gRPC, like HTTP, different versions. And it is important that all your Servicemesh that actually help you to track all your transaction using TCPs. That is something that I want to explicitly mention. It is not only tracking the L7 level of controls, it can also go to the other layer and give you a more perspective and to help you to understand the way how the network flow is actually happening. And of course, API support is mandatory. I would say because it's moving through APIs, because if your service mesh is going to be an overburden to an existing container system, and just to tell you, service mesh can be installed with any of your container system. It could be with Kubernetes and Docker. It could be with Mesos orchestrations, or you can have a different orchestration for containers. And your service mesh is actually a platform agnostic. And if it does not support those CRUD operations from the specific container orchestration technology, this is going to be a failure. So this is pretty much the interesting thing that Servicemesh is offering in terms of how you can do out of the box traceability, how you can ensure a proper security at the service layer, and how you can actually do explicit level of control by using a centralized mechanism, and how it makes sure your communication is actually having the proper resiliency, circuit breaking, and support of multi-protocol. There are different service mesh tools that can go well with Kubernetes, and everything has its own advantage based on the context. And we will be talking about Linkerd, one of the interesting products that's part of CNCF, and a couple of other products like Istio, Console Connect, and a few other topics in the coming sessions. Thank you. In the next video, we'll give you a practical perspective of how we can implement Linkerd with Kubernetes.